Yes. So if you said negative right here, that counts as the same as saying the direction toward. So you could have said a constant speed of and toward, or you could put the negative sign in your value as well. So the ones that had a positive slope, if you wrote the plus sign on both of those, that would have been credit as well. But as long as you indicated toward or away, then I didn't have to have the plus and minus because you said the direction in it. But if you did both, then that was fine. Okay. Anything else on those, on that one? Okay, so position time graph, away, still, toward, still, and away. And all of those velocities were a constant value, and you should have given a number. So they walked at a constant pace for those. If it had not been a constant pace or speed, then they would have been parabolas. That's how they would have been accelerating or decelerating. On the next one, we had a velocity time graph. And it looked, oh, sorry, helps if I switch pages. So on this one, we actually have some positive and negative values. So it went like this, and then the origin, then down. It looked like that. Okay. So from here to here, at the first part, okay, right here, did they have a velocity or were they standing still? They had a velocity. Was it positive or negative? Positive. So by positive, you could have said forward or away from the motion detector. So anything positive would have still been walking away from. And it was a constant velocity of, and then it was positive 2 meters per second. So I'm just going to put the number up here. So they were walking away at a constant 2 meters per second the whole time. And then it suddenly drops. The lines that go vertical on your graph, that's just to connect to get down to where the next point on the y-axis needs to be. From here to here, do they have a velocity? No, so what are they doing? Yeah, standing still. So from yours, that would have been the 4 seconds to the 7 seconds, they were standing still. And then what's happening down here? Direction-wise, oh, it lost. Sorry, it unplugged. So when you see a velocity that's a negative, what's that tell you about the direction? Yeah, it's toward. So down here, they switched directions, okay, and they had a constant velocity of 3 meters per second. So if you had indicated a negative, that's okay, or you could have said 3 meters per second toward, or some combination of both. Okay, but you need to have a direction somewhere indicated either by the negative sign or the words. Okay. And then this is where it gets a little tricky. Okay. So this little section right in here. Okay, so let's look at that. When they're down here, is that a positive or a negative velocity for this little section? It's a negative velocity. They're still below the axis. Okay, and I think I just counted 1 or 2 points off if you guys messed up this little section. And it was a pretty common mistake, so I just want to make sure we went over it. So from here to here, it's still below that x-axis, so it's a negative velocity. They're still walking toward the origin. Okay, so even though it gives you a positive slope value, they're actually walking toward the origin still because it's a negative number. And you could have found the slope just for that little section. Okay. So from -3 to 0 at that point. So they actually slowed down because they had a high magnitude. They were at 3 meters per second, but then they slowed down. Okay. From here to here, see how that changes to a positive velocity? If you go from negative to positive, the plus and minus, those are your directions. So even though that part of the graph looks like it continues in the same direction, the person actually walking, because that switches to a positive, They're walking away from the detector. So at this big point, right in the middle, they switch directions right there where it crosses that x-axis. So they were going toward the origin pretty fast, and then they slowed down, and then when it hits that time where it crosses the axis, they change directions. And see how the velocity gets bigger from 0 up to 1? So they actually increase their speed. They're getting faster as they walk away. Okay. So that little sloped area was the one that gave people the most trouble. Okay. And then back to the flat part, positive or negative?
Positive.
Positive, so toward or away? Away. And was it a constant or? Okay, so that one was a constant one, and that was +1 meters per second, or you could have said away at 1 meter per second. And then down here, positive or negative? Negative, so they switched directions. So now it's toward, and that one was at 2 meters per second, or you could have said -2 meters per second. Okay. Is there anything you'd like to go over on that one? The velocity graphs are really hard to interpret just because it's kind of backwards, like from your normal thinking. You're used to seeing position. Yeah.
So the little sloped part, the negative velocity, they're decelerating.
Yes.
And then they switch directions, they accelerate.
Yes.
So you really can't find the slope for that part. You just have to look at it and like.
Yeah, you could have found the slope from 9 to 10.5 seconds.
Okay.
And so that would have been 3 over 1.5. So you could have done a number with that, but if you at least told me that they were slowing down and the direction, I gave you points. Okay. Is there anything else on those? So on the sloped part, they're going toward it, but slowing down, and then once it hits where this little green dot was, they switched directions and moved away and sped back up. Anything else on that one? The next one I took from your summer assignment. Kind of played with the graphs a little bit. When you dropped a ball, you guys had just one direction going down. So in this part, I added an up and a down. So when we look at our graphs, for the position time graph, the numbers I was looking for, the ball was in the air a total of 2 seconds. And it went up 2 meters, and then it came down 2 meters. So when you look at that, we're assuming there's no air resistance, and some of you asked, is it go up for half the time and down for half the time? Yes. Okay. So we started out on the ground. It took 1 second to go up 2 meters, and then 1 second to go down 2 meters. Because, does it change its speed as it lifts? Yeah, it slows down. And then it turns around, and when it falls, gravity's making it go faster and faster. On your summer assignment, on your position time, a lot of you had one that looked like that. It was the second half of the parabola. So all we did was add the up part, and then this was the down part. Okay, so you should have had a parabolic shape. That's what I was looking for. Questions on that one? On the velocity, I know, I'm so used to doing the axis at the bottom. Okay. So on the velocity time graph, you still need 2 seconds. That was the time it was in the air. And since there's an up and a down, we've got a -1 and a -2. Okay. So on the way up, it had told you to consider the up part in the positive direction. So that first 1 second, you should have been on the top half of the graph, somewhere in the positive section of the graph. Okay. Think about something as it flies upward. Okay. As it goes up, is it speeding up or slowing down? Slowing down. So we were still positive because it was moving in the positive direction, but it was slowing down until it reached that halfway point. Okay. Here at the 1 second, that's where it turns around and it falls back down. So now we're in the negative part of the graph because down is negative. And does it speed up or slow down as it falls? Speeds up. So I go from 0 velocity to having a much bigger velocity. Okay. Some of you guys did that, which was kind of the right idea. You knew that the positive and negative part were right, but it wasn't a constant velocity. It actually changed. So it slows down and then it speeds back up. Okay. So velocity time graphs, you want to think about anywhere above the x-axis, that's a direction. That's moving either forward or up. Anywhere below the axis is moving backwards or down. Okay. And then numerically, you can look on if the velocity goes from a high one to a low one, and then a low to a high. So slowing down and speeding up. Okay. And then what did you learn from your summer experiment about? Okay, so it should have been constant. What made things fall down? Gravity, which was negative. So I was looking for something somewhere around negative 9.8. That should have been the value that you found in your summer lab from gravity. Yeah.
So when the velocity time graph, it should just be like a constant.
Yeah, it should be a constant straight, yeah. Yeah.
Why is it, I thought it was positive 9.8 if it's going straight down, is that not?
Because there's an up and a down. It had said that up was positive in the description and considered down to be negative, and gravity's always pulling something down.
Okay.
So, oh, go ahead.
So no matter which direction it's moving, it's still.
Right. So the reason that, remember you guys told me that it slowed down when it went up? That's because gravity's pulling it. It's trying to make it come back down. So you start out with a pretty big velocity going upward, but gravity's working against you, and that's what's slowing it down. It's like those of you guys that in your athletic training, you do those things where you run and then the bands pull you back, like they're working against you to slow you down. That's what gravity's doing. So even though the object's trying to move up, gravity's pulling it down, and that's why it slows down. And then eventually gravity wins, in a sense, and it makes it turn around and come back, and it's still making it accelerate in that direction. So gravity's pulling it down. Constant value, because we don't have any kind of air resistance, so it's the same value for acceleration all the way across during the whole graph, the whole time. Okay. Anything else on the graphs? Okay. Usually you'll have interpreting graph questions on the AP exam, so that's why we're spending some time with those. Okay, so everyone should have the astronaut question. It tells you that a feather is dropped from 3.1 meters. And whenever you drop something, how much initial velocity do you have before you let it go?
0.
0, good. So we have 0 initial velocity. Okay. And then it tells you that the acceleration due to gravity is 1.65 meters per second. Okay. And then it wants to know how long it takes. So our formula for the kinematic equations that had all of that in there look like this. Or you could have said an A right here where I put G. It's due to gravity, so either one. Since there was no initial velocity, I can cross out that whole term. Okay. And then you're welcome to rearrange. Some people do this differently. They plug numbers in first and then rearrange, or you can rearrange first and then plug it in. Okay. I'm going to go ahead and just put the numbers in. So I had 3.1 meters, and that equals half. And then they gave us I left off the 5. 1.65 meters per second squared, and then t squared. And some of you guys might wonder, when we talked about gravity before, it was pulling down in the negative direction. On this particular question, something is only falling in one direction. So you don't have to make that distinction. If it's easier for you to always think of gravity as being negative, you can put that negative sign here, but your displacement is also down, and you would have had a negative sign for the distance as well, and those signs would cancel. So if everything's in one direction, they end up canceling with each other anyway. So I had left it out at the beginning. From here, you just need to rearrange and solve, and you should get 3.75 repeating on the t squared. And then you would need to take the square root at the end. And you should have gotten about 1.9 seconds. Any of them on that one that you want to go over? Hopefully the math, the actual word problems were a little bit easier than the graphs. And I think when I was grading them, you guys got a lot more credit on these than you did on the graph points. Okay. So our next one, we had an airplane. And this time it did give you direction by indicating the plus sign in the question itself. So I went ahead and maintained those directions of, so I was given an initial velocity of I actually already wrote dA plus dB. So I'm gonna change that and say velocity of car A times the time.